Testing 1, 2, 3. I hope this is working. Please, we're going to start. Please take seats. Please direct your attention in this direction. Before we begin, since this is the Society of Catholic Scientists, we'll begin in prayer. Let's say a little crown. Our Father, Holy be. In the name of the Father, and the Son, the Holy Spirit. Amen. Our Father, who art in heaven, hallowed be done, on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses, as we forgive those who trespass against us. And lead us not into temptation, but deliver us from evil. Amen. Hail Mary, full of grace, the Lord is with thee. Blessed art thou amongst women, and blessed is the fruit of thy womb, Jesus. Holy Mary, Mother of God, pray for us sinners, now and at the hour of our death. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit, as it was in the beginning, is now, and ever shall be, world without end. Amen. Come, Holy Spirit, and inflame our hearts, and make us effective apostles in this world. St. Thomas Aquinas, St. Albert the Great, pray for us. Okay, our speaker today is Professor Stephen Barr, a Professor Emeritus of Theoretical High Energy Physics from the University of Delaware, also the President of the Society of Catholic Scientists. I believe he got his PhD at Princeton, is that correct? I'm just the guy who runs a local chapter, nobody of any great importance. I think you all know me anyway. So let us begin without further ado. Okay. And I'm going to clip this to you. This is for the recording.
All righty.
That goes sort of go like that, I think. Okay.
Okay, and it's on. Good. All righty. Let me just put my bottle of root beer here. So this is about as loud as I'm going to talk. So can you hear me, everybody? Okay. I have 5 kids, and so I have many years of yelling at my children, so I have lung power. But if I start to get not loud enough, then you may have to move closer. So the title of my talk is the human mind reducible to physics? Some people think that there's a conflict between science and religion. However, the real opponent of religion is not science. It's a certain philosophy called scientific materialism. What is that? So materialism, in the philosophical sense, is the claim that only matter exists. And scientific materialism is the claim that materialism is somehow implied by modern science. This philosophy is also called physicalism nowadays, because it says that everything is physical and all of reality is reducible to ultimately be accounted for, therefore growing visibility and influence of includes such people as Richard Dawkins, Daniel Dennett, Sam Harris, Lawrence Krauss, and on and on. But it's important to realize that these scientific atheists, or these atheists, are not just atheists. They're also materialists. And materialism is a much more radical point of view than atheism. Atheism just says it doesn't exist. But materialism says nothing exists, God except matter in motion. And that would mean that even a human being is nothing more than a complex structure made of atoms. So what's being fought over is not only God, but also ourselves and what we really are. The ongoing battle is between 2 radically different conceptions or views of what a human being is. It's what you are. So what is a human being? The scriptural answer is that we are made in the image of God. St. Irenaeus of Lyon, the great 2nd century theologian, explained this as follows. He said, we're made in the image of God in this way. Man is rational and therefore like God. He is created with free will and is master over his acts. And indeed, the Church has always taught that reason and free will are the 2 powers that make us spiritual beings. But what about love, you might ask? Well, love comes from our freedom and rationality. It's love, in the Christian sense of love, is not simply a feeling, emotion, instinct, or affection. It is the free willing of the good of the other person. Only a being who has reason and freedom can love in this sense. So these two spiritual powers of reason and freedom are inseparable. They're connected together. Free will is the capacity to make choices for reasons, not just from some blind impulse, but for reasons, and reasons having to do with you. And conversely, the power of reason presupposes that our minds are free. If our minds were entirely controlled by factors of a lower order, as the minds of animals are, for example, by the physics and chemistry in our brain, we could not be open to realities of a higher order, such as truth, goodness, and beauty. All this is summed up very well in the Catechism of the Catholic Church, which is actually quoting from Vatican II. And it says that a human being, quote, in his openness to truth and beauty, his sense of moral goodness, his freedom, and the voice of his conscience, finds evidence of his spiritual soul, which is irreducible to the merely material. But this conception of human beings is not as plausible to many people today as it once was. Reductive theories abound that claim that human beings are nothing more than the product of biological and social evolution, of genes and the environment, of instincts and social conditioning, of the wiring of the brain, of hormones and and the chemistry transmitters, and so on. In other words, purely physical factors. Our minds are nothing but, they say, the processes going on in the enormously complicated biochemical computer we call the brain. So that's the materialist view. Here are two quotes that express it very well. One is from Carl Sagan, who wrote, "I am a collection of water, calcium, and organic molecules called Carl Sagan." Sir Francis Crick said, your joys and your sorrows, your memories and your ambitions, your sense of personal identity and free will are in fact no more than the behavior of a vast assembly of nerve cells and their associated molecules. Okay? So, now where did this view come from? It has deep historical roots. The predictable motions of the heavenly bodies led very early on to the idea that the astronomical universe is just a clock-like mechanism. In fact, it was already commonplace in the Middle Ages for philosophers to call the universe a machine. In the 17th century, as it became clear that earthly phenomena, like celestial ones, are governed by precise mathematical laws, the idea began to emerge that terrestrial things are also machines. The plants, animals, and even the human body can be understood as machines. There was a great deal of interest in the 17th century in automata, and the idea that animals and the human body are automata. That was the view of Descartes, for example. Though he believed that human beings, he was a believing Catholic by his own testimony, and he continued to believe that humans have a spiritual soul. But the more radical thinkers of the 17th and 18th century went further. They denied the spiritual soul and its freedom, and asserted that man in his entirety is mechanical. A famous book written in 1948 by Baron Lamettrie had the title L'Homme Machine, or Man Machine. Now, such thoroughgoing physicalism was still rare in those days, but it has gained enormous traction in our own day. As computer technology has advanced, many people have become accustomed to the idea, popularized by science fiction, that artificial machines might eventually become as conscious and intelligent as we are. And now we're seeing with ChatGPT that this is even being reinforced more, this view. The natural corollary of the idea that we ourselves are just, quote, machines made of meat, in the words attributed to Marvin Aminsky, a pioneer of artificial intelligence research. They attribute it to him because I looked on the internet, I can't find out where he ever said this. But the phrase "we are machines made of meat" is commonly used. Now, many factors have contributed to this development. One was the defeat of vitalism in the 19th century. Vitalism was the idea that there's some kind of life force that living things have. It was shown in the 19th century that life processes are based on the same chemical elements and laws of chemistry that are found in the non-living world. And this suggested that the same reductive modes of explanation that have been so successful in physics would unlock the secrets of biology as well, as they have to a remarkable degree. And Darwin's discoveries, by showing the continuities that exist between ourselves and lower animals, weakened belief that humans are in any way really exceptional. But a decisive shift had already occurred long around 1700 before the discoveries of Isaac Newton. So Newton's laws of gravity and mechanics had two profound features. First, they were universal. They governed everything, from the motions of the great planets to the minutest constituents of matter. Second, they were deterministic in a precise sense. They implied, Newton's laws implied that the state of the physical world at one time completely and uniquely determined its state at all future times. In other words, if you knew exactly where all the particles in the world are and how they are moving at one time, it would be possible, in principle anyway, to calculate how they would be moving at all subsequent times. The classic statement of physical determinism was given by the great mathematical physicist Pierre Simon Laplace, who in one of his books wrote, "To an intelligence which could know all the forces by which nature is animated, and the states at some instant of all the objects that compose it, nothing would be uncertain, and the future, as well as the past, would be present to its eyes." Every discovery in physics in the century that followed that bore out that view of things. When the complete laws of electricity and magnetism were written down by James Clerk Maxwell in the 1860s, for example, they were seen to be as rigidly deterministic as Newton's laws of mechanics and gravity. Now, this determinism, this physical determinism led to the idea, gave to the belief that the entire physical universe is a complete and closed system of cause and effect. This is often called the principle of the causal closure of the physical world. Now, according to this principle, physical events can be completely accounted for by prior physical causes, and indeed, therefore, there are no other causes of these events than physical causes. Physical events have only physical causes, and those physical causes can completely account for them. Now, if that's true, if physical events can have only physical causes, and then non-physical entities, even if they existed, such as a human spiritual soul, would be irrelevant. They'd have no effect on the world of matter. So whether you have a spiritual soul would be irrelevant, since it could not affect what you do or what you say, or even what is happening in your brain, because those are physical events, can have only physical causes. Your brain, as much as the rest of your body, would be under the inflexible control of the laws of physics, and freedom, at least freedom of action, would be impossible. You might say this is nothing new. I mean, this was nothing new. There had been thinkers since antiquity who denied the reality of human freedom, claiming that our thoughts and deeds were governed by the stars or by fate or something else. But those ideas were the fruit of mere speculation. What made the Newtonian challenge to free will more pressing was that it came from a very powerful scientific synthesis that had proved its validity countless times over hundreds of years of research. This doesn't mean that scientists after Newton immediately abandoned belief in free will, or that Newton himself did, or in the existence of a spiritual soul. Most scientists, up until at least the mid-19th century, including Newton and Maxwell, rejected materialism. They did believe, and they rejected this idea of the causal closure of the physical world and the materialist view of the world and of human beings. Nevertheless, materialist ideas slowly gained ground, and for many people today, they're axiomatic. So in the remainder of this talk, I'm going to sketch 5 pieces of evidence or lines of argument that suggest there's more to the human mind than physicalism can explain. Some of these are based on ordinary human experience, and some are based on profound and revolutionary developments in mathematics. Now, the first piece of evidence, physics, is the phenomenon of consciousness, which I'll argue cannot be explained in purely physical terms, in physics terms, in other words. Even animals who lack the spiritual powers of reason and free will seem to have consciousness. So what I'm arguing is that physicalism fails even to account for mental phenomena that fall far short of the spiritual level. They can't even account for animal minds entirely. And that's one reason why some well-known philosophers of our time who do not believe in the human spiritual soul, such as Thomas Nagel and David Church, for example, nevertheless reject the materialist picture of the mind. They believe that such a picture cannot account for consciousness. Now, in consciousness in general, let's focus on one particular kind of conscious experience, color sensation. Can physics explain why an apple looks red? In other words, can it explain that? Okay? Now, there you go. Now, many scientifically knowledgeable people would immediately answer, yes, physics can explain why an apple looks red. They would say that red light consists of electromagnetic waves of certain wavelengths. They would say that physics can explain why the skin of an apple preferentially reflects light of those wavelengths. They would then speak of the cone cells in our retinas, the visual cortex of our brains, and so on, and how these allow our brains to distinguish light of different wavelengths. Does all of that add up to an explanation of our subjective experience of redness? It does not. As the philosopher Frank Jackson argued, and he had this thought experiment that he proposed, which has become a famous argument in philosophy. He said, imagine a person, he called her Mary, who had never been exposed to color. In particular, she had, in his experiment, had been raised in a completely black and white environment and had never seen color. But Mary has a complete knowledge of all of the laws of physics. So she's living sometime in the future. She knows all the physics there is to know. And a complete knowledge of biology, of human physiology and what goes on in the brain, the biological level, when somebody is seeing color. So knows all the physics and biology. But she would still have no idea what the color red looked like. She would have no idea what the sensation of redness was like. Which shows, now if she then were shown something red, she would know something about reality, says Frank Jackson, she hadn't known before. She would know something that she hadn't known before, which shows that all of her complete knowledge of physics did not give her access to that thing that she now knows. Now, discussions on this topic are often confused by the fact that some people mix up quite different notions. On the one hand, the physical characteristic of a material entity that we access through sensation, and on the other hand, the sensations themselves as mental experiences. There is the redness of the apple as a property of the apple that it would have even if no animals had ever evolved that could see. There's a sense in which the apple has a property of redness. And that has to do with how it interacts with electromagnetic waves, with how it electromagnetic, and the fact, as I said, that it preferentially reflects light of certain wavelengths. That would be true even if no creature had ever evolved that could see anything. That's an intrinsic property of the apple. But then there is the redness of the apple in the sense of the color sensation that is in our minds when we human beings look at the apple. Now that may be a different sensation that maybe a dog, but most dogs are colorblind, but take some other animal that can see color, they may have different sensations. So for them, red is a different sensation. But those are two different things. The property of the apple, the physical property of the apple, and the sensation of redness. You can illustrate this by thinking about a device that it would be simple for any engineer to build that could recognize whether the difference between the redness of the apple and the yellowness of a banana. It could tell the wavelengths were different. It could even print out and say the apple is red or this banana is yellow, but it's not experiencing any sensation, color sensations. It would no more be experiencing this device, the sensation of red or yellow, than a thermostat or a thermometer feels warm or cold. Okay, so there's two different things here. Now, that physics can explain the wavelengths of light and how things interact with them is clear. Physics can also explain temperature and the flow of energy in the form of heat. The question, however, is whether physics can explain the subjective experiences of color and warmth that are part of our consciousness. And it seems fairly clear that it can't. It's a question of the very nature of physics and how it explains things. In physics, every physical system is completely characterized, indeed, you might say defined, by a set of mathematical variables, observable quantities that are expressed in some mathematical variables that describe what its smallest constituent parts are doing. The variables might be, for example, the positions of particles or the of field strengths. Now, how those variables change over time is governed by a set of mathematical rules, the laws of physics. Now, most physicists, including myself, believe that if one knew what all the variables of a physical system were and their values, and how those values were changing with time and the equations that governed them, one could, in principle, not necessarily in practice, but in principle, derive everything there was to know about the system's physical properties and behavior, using only the rules of mathematics and logic. And this is sometimes called physical reductionism. It's the spectacular success of that kind of reductionism in explaining so much about the world around us that underlies the confidence of physicalists that it can be extended to explain everything. It seems obvious, however, that it cannot be applied to consciousness. Even if one knew presented with some unfamiliar physical system, and if determined what all the variables describing it are, all the degrees of freedom, all the equations governing them, and so on, you would not be able to derive from that knowledge any conclusion about whether that physical system or entity was conscious, was experiencing anything at all, had any subjective experiences. You know, like in the old Star Trek show. Imagine you're on some planet and some purple blob comes up to you going, you know, and you take your tricorder. So you actually figure out all the degrees of freedom, all the variables, its physical structure completely, down to the minutest subatomic particle or whatever. And you know all the equations. You can't derive from that, by logic and mathematical reasoning, you can't derive any conclusion about whether that thing has any subjective experiences or not. You might have your suspicions. Now, of course, we sometimes do conclude from the physically observable behavior of some being that it is having feelings. When my dog, may he rest in peace, well, I don't think he's resting, I don't think he exists anymore, but my poor dog Sparky, when he smelled bacon, he got all excited. And when he was eating the bacon, he got even more excited, and I have no doubt that he enjoyed the smell and taste of bacon. It had these, what philosophers, he had these experiences and sensations, and then he was conscious. Now, but that's really an inference based on the fact that he's behaving much as I would. I would jump around excitedly. It's an analogy. I could, if I were perverse and foolish, I might say, I don't believe that Sparky has consciousness at all. I think he's just an automaton. He's a machine that reacts in certain ways to molecules wafting through its nostrils and sets off this chain of reactions in its nervous system and blah, blah, blah. I could deny he had any consciousness, and you couldn't prove me wrong from the equations of physics. Might be foolish to deny it, but I would not be contradicting physics and chemistry. So, in other words, it's not, and that's because things such as the scent of bacon, the taste of bacon, the scent of a lilac, the sensation of the color pink, they're not quantities that appear in the equations of physics. Okay? The way the positions of particles or the strengths of fields do. If I were to, in other words, it's not just that we don't yet know how to give a physics explanation of consciousness or sensory experience. It is that physics, by the very way it explains phenomena through mathematical and logical analysis, cannot, in principle, explain these things. As Schrödinger said, all scientific knowledge is based on sense perceptions, but the scientific views of natural processes formed in this way lack all sensual qualities and therefore cannot account for the latter. So we need to use our sensations to interact with the world and to know anything about the physical world. But then when we get our physical theories, which is all a bunch of equations and mathematical rules, those physical theories that, of course, we needed to have sensation in order to have access to the world and to develop the theory, but the theories themselves lack all these sensual qualities and can't account for them. I'd like to quote a great physicist of our own day, Edward Witten. Many physicists regard Witten as the most brilliant physicist alive today. He's not religious. He describes himself as a skeptical agnostic. In an interview a couple of years ago, he was asked whether he thought anything, whether we would ever know all the laws of physics, would we ultimately get the ultimate laws of physics someday? Would we know what they were? He was optimistic that he thought might get there. And then he was asked, once we know all the ultimate laws of physics, do you think anything will remain mysterious at that point? And he said yes, and he actually listed 3 or 4 or 5 things that he thought would still remain mysterious, and one of them was consciousness. He said, I tend to think, he was a little redundant, but this is, I tend to think that consciousness will be a mystery. That's what I tend to believe. I tend to think that the workings of the conscious brain will be elucidated to a large extent. So I tend to, that biologists, with perhaps physicists contributing, will understand much better how the brain works. But why something we call consciousness goes with those workings, I think will remain mysterious. Perhaps I'm mistaken, but I have a much easier time imagining how we'd understand the Big Bang, even though we can't do it yet, than I can imagine understanding consciousness. Now, the interviewer was not happy with this answer, and he asked, define consciousness. You know, it's a famous ploy. Define consciousness. And Witten replied, I'm not going to attempt to define consciousness. In a way, that's connected to the fact that I don't think it will become part of physics. I left out the word the. To the fact that I don't think it will become part of physics. I am skeptical that it's going to become part of physics. Okay, So it's not just, the arguments I'm making up this point have nothing to do with religion, actually. They're atheists, philosophers, atheists, or non-believing scientists on purely sort of non-religious grounds who argue that consciousness goes beyond physics. But let's put aside the problem of consciousness, and let's turn to another phenomenon that points to the falseness of physicalism or materialism. And this actually gets to the spiritual powers that human beings possess and that presumably my dog Sparky does not. And that second feature of the human mind is its ability to think abstractly, to understand abstract concepts. So what is an abstract concept? Well, maybe the best, this is of course a very difficult topic and I'm not a philosopher, but maybe the best way to explain it is through examples. If you think about a particular person, you're not thinking abstractly, but if you think about personhood, you are. Terms such as personhood, truth, impossibility, justice, or triangularity are what medieval philosophers called universal terms, universals. The word triangularity, for example, is a universal because it does not refer to this or that particular triangular object, this piece of wood or that slice of cake, but to all real or imagined triangular objects, or possible triangular objects, ones that don't even exist. Indeed, it can be understood, the concept of triangularity, apart from any concrete example of it. Thus, when we understand the meaning of a universal term apart from any particular object that we're sensing, for example, we're engaged in truly abstract thought. So abstract thought has, in a sense, a kind of universal reach, an unlimited reach. It transcends, such concepts transcends what is here and now and the particularities of specific objects or objects of sensation to embrace a concept whose scope is infinite. For this reason, a philosophical tradition going back at least to Plato and Aristotle has argued that nothing which is merely material can engage in abstract thought. And the argument is as follows. A particular, or this at least is one version of the argument, a particular material entity can exemplify or embody an abstract concept, the way a piece of wood or a slice of cake can exemplify triangularity. But no material object can exemplify all ways of being triangular. Equilateral triangles, right triangles, scalene triangles, and so on. There are an infinite number of triangular shapes. Or take the concept of a mathematical curve, a continuous curve. The orbit of a comet around the sun may exemplify a specific continuous curve, or the shape of a bent piece of wire, such as a hyperbola or parabola. But no particular material entity or system can exemplify or embody all continuous mathematical curves. So the concept of a continuous mathematical curve can't be, the general concept, the universal concept, can't be embodied in a specific concrete material object. And therefore it cannot be inscribed or embodied in the human brain, which is a concrete particular material object. So when the human mind understands an abstract concept or grasps the meaning of a universal term, something more than the brain must be involved. So this is the old argument. Now I'm focusing on abstract concepts from mathematics for two reasons. First, because mathematics is the realm in which abstract thought is at its purest and most precise. And second, because the theories of modern physics are constructed from mathematical concepts. So if the materialist or the physicalist philosopher who thinks that everything is reducible to physics cannot make sense of the abstract concepts of mathematics out of which physics is built, he'll not be able to make sense of physics. And that would be quite an embarrassment to his position, since he said he thinks everything is physics. So let's look at the abstract mathematical concepts called numbers. There's a whole branch of philosophy called philosophy of math, which I've always been fascinated in. What are numbers? What is the materialist who thinks everything material? What is he to make of the number 4, for instance? It's not a physical object, obviously, but maybe it is an aspect of physical objects. For example, one might think of it as an aspect of a 4-sided table or a 4-footed animal. That's what 4 is. It's an aspect of material objects. That might work for the number 4, but it won't work for most numbers. For example, it won't work for the number pi or the 7th root of 19. Now, some might say, well, pi is an aspect of circular objects like these tables. It's the ratio of the circumference to the diameter of the table. Well, there are no exactly circular objects in the world. That's one problem with that idea. But even leaving aside that, it's hard to see how a number like the 7th root of 19 can be an aspect of a material object. If you can think of a way it can be. I can think of the square root of 2. It's the diagonal of a triangle whose legs are length 1. But some number, 7th root of 19, if you can think of a way that can be an aspect of a physical object, let me know. Now, some philosophers would say, and I would agree with them, that numbers are neither material objects nor just aspects of material objects, but are rather mental objects. You cannot touch a number, but you can think a number. You can understand a number. You can grasp it not with your hands, but with your mind. So many philosophers of mathematics would say numbers exist, mathematical entities exist in minds. This is of no help to the materialist, however, because he sees minds as themselves material entities, merely the functioning of material systems, the brain. The former editor of Nature, Sir John Maddox, wrote, "An explanation of the mind must ultimately be an explanation in terms of the way neurons function." And an article in Newsweek once explained the implications of some neuroscience experiments this way: thoughts are not mere will-o'-the-wisps, ephemera with no physicality. They are instead electrical signals. So thoughts, ideas, and presumably including mathematical ideas, like the number pi, square root of 17, they're just electrical signals. Well, if minds are just neurons and electrical signals, and numbers are in minds, then we would have to conclude that the numbers pi and the 7th root of 19 are just electrical signals in someone's central nervous system. Indeed, some would go that far. A science article in the New York Times some years ago said, "Numbers are neurological creations." Okay? Our nervous systems give rise to them. So all of mathematics, all of theoretical physics, including quantum mechanics, the theory of relativity, and so on, are just electrical signals in some nervous system of some strange mammal. And that gives them no more status than a toothache. But we've already seen one fatal difficulty with this whole idea. The full range of an abstract concept, being infinite, cannot be inscribed, or so the argument goes, in any particular finite material system, and that would include a human nervous system. Now, an objection might occur to someone at this point. Don't we express mathematics in symbols and formulas written on paper or on blackboards or in digital form in our phones and so on? Maybe mathematics is not a matter of abstract concepts or thoughts in a mind at all. Maybe mathematics is just a matter of manipulation of symbols and formulas, which clearly can be inscribed in various material systems, like blackboards on pieces of paper. There is a school in the philosophy of mathematics that takes this view. It's called formalism. There is some plausibility to it. After all, much of mathematics can be done by the mechanical manipulation of symbols. Think of what you do when you do long division, for example. And that is why computers can do mathematical calculations and even prove mathematical theorems. I'll come back to discuss the formalist view of mathematics very soon. But first I want to discuss another capacity of the human mind that raises severe difficulties for physicalism. And that is the capacity of the human mind to recognize truth. The problem that this raises for physicalism is the following. If our thoughts are simply following a path set out for them by the laws that govern matter, by physics and chemistry, as the physicalist believes, then how does truth come into the picture? In the final analysis, my thoughts and beliefs are not guided by truth or perceptions of truth. They are just the thoughts that I must have given the way the laws tell the molecules in my brains to move, and the electrons and so on. In 1932, the famous biologist J.B.S. Haldane made the following argument. He said, if materialism is true, it seems to me that we cannot know that it is true. If my opinions are the result of the chemical processes going on in my brain, they are determined by chemistry, not the laws of logic. Other people have made similar arguments. For example, G.K. Chesterton in his book Orthodoxy, a brilliant little book that everyone should read, written in 1908, he noted that the materialist skeptic must sooner or later ask, quote, why should anything go right, even observation and deduction? Why should not good logic be as misleading as bad logic? They are both movements in the brain of a bewildered ape, he said. He just had a way of saying it. They're just movements in the brain of a bewildered ape. Now, interestingly, Haldane later changed his view. From rejecting materialism, he changed his view and accepted it. And the reason he reversed his position and embraced physicalism was the development of the computer, which demonstrated that a machine, which is clearly just operating by the laws of physics, would also nonetheless be also able to follow the laws of logic. The reason Haldane ended up being misled is he didn't quite frame the issue right in the first place. The real issue is not whether a machine can follow the laws of logic. Certainly it can. If designed and programmed properly, a machine that follows one set of rules, the laws of physics, can, in doing so, also be following another set of rules, the laws of logic or arithmetic or chess. The real question is whether a machine that is only blindly following rules of whatever kind can be open to the truth. The answer seems to be no. Even if we restrict our attention to the realm of mathematics, openness to truth seems to involve more than the mere mechanical following of rules. That seems to be the lesson of one of the great discoveries of the 20th century, Gödel's theorem, or Gödel's theorems. Before the great logician Kurt Gödel proved his theorems in 1931, the school of thought called formalism was very influential in the world of mathematics, or at least philosophy of mathematics. According to the formalists, all of mathematical reasoning can be reduced to symbolic manipulations that follow prescribed rules. So all of mathematical thinking could be reduced to operations that a machine, such as a computer, could perform. Now, according to the formalists, to say that a mathematical proposition is true simply meant that it can be derived from certain prescribed formulas, called axioms, by following the prescribed rules, mechanical rules of symbolic manipulation. Consequently, the following of mechanical rules could give one access to all of mathematical truth, because that's what mathematical truth is. In 1931, Gödel stunned the mathematical world by showing that this view of mathematical truth is inadequate. He showed that no matter how many rules one prescribes, there will always remain infinitely many truths of mathematics that cannot be reached merely by following those rules. Thus, even in the bloodless realm of mathematics, the power of reason and its ability to reach the truth involves something more than machine-like behavior. Truth is, even mathematical truth is something beyond and above just mathematical, or just blind rule following. Now, computers can manipulate symbols blindly by following rules, but human minds do something much more profound. They grasp the meanings of the symbols and the truths implied by those meanings. Our thought processes are guided not only by rules, but by understanding as well. That's why a calculating machine is not a mathematician. Some famous person, and I think it may have been Samuel Johnson, but I haven't been able to track it down. My father told me this quote, said, "A horse that can count to 10 is a remarkable horse, but it is not a remarkable mathematician." And the same is true of any machine. Hermann Weyl, one of the great mathematicians of the 20th century, said in a lecture at Yale University in 1931, Descartes, oh, well, this is not, I have a different quote. Let me go back. This is a different quote from Weyl. He said, Descartes brings out the decisive point with particular clarity when he demonstrates the freedom involved in the theoretical acts of affirmation and negation. When I reason that 2 + 2 = 4, this actual judgment of truth is not forced upon me through blind natural causality, a view which would eliminate thinking as an act for which we can be held responsible or answerable, but something purely spiritual enters in. Weyl went on to explain that thought processes that were entirely determined by physical factors, such as the chemistry in our brains, would be, as he said, groundless and blind, and instead, he said, rational thinking must be open to meaning and truth, and therefore must be free. This is profoundly in harmony with the passage I quote from the Catechism of the Catholic Church, which spoke of human beings' openness to truth and beauty, his sense of moral goodness, and his freedom, as evidence of our spiritual soul, not reducible to merely materials. So I'm almost at an end. Now at this point, one runs into an objection based on physics. As I mentioned earlier, for centuries there was a mounting evidence that the laws of physics are deterministic. That is, that they rigidly determine how events will unfold. This created great difficulties for the idea of human freedom, not only moral freedom, but intellectual freedom. And it was a powerful argument in favor of the causal closure of the physical world and that everything was machine-like. So are the laws of physics deterministic? This brings me to my final topic, quantum mechanics. In the 1920s, theoretical physics underwent a revolution. Its conceptual foundations were changed in a profound way. And these new foundations, to everyone's surprise, were non-deterministic. According to the principles of quantum mechanics, the state of a physical system at one time does not rigidly determine its future, contrary to what Laplace had famously said, but only determines the relative probabilities of various different possible outcomes. All of a sudden, one of the most powerful arguments against free will was swept aside. And let me quote again this great mathematician, Hermann Weyl, from the same lecture. He said, "We may say that there exists a world causally closed and determined by precise laws, but the new insight which modern quantum physics affords opens several ways of reconciling personal freedom with the laws of physics. It would be premature, however, to propose a definite and complete solution of the problem. We must await the further development of science, perhaps for centuries, perhaps for thousands of years, before we can design a true and detailed picture of the interwoven texture of matter, life, and soul. But the old classical determinism of Hobbes and Laplace need not oppress us longer." And now I get to my final topic. Well, very briefly, there's another way in which quantum mechanics has profound implications about the nature of mind, or at least many have argued this. The traditional way of understanding quantum mechanics requires that there not be only physical systems that can be measured and whose behavior can be calculated, But there must be someone doing the measuring, traditionally called the observer. The things being measured are physical, but the logic of the theory, according to some people, implies that the one doing the measuring, the observer, cannot be entirely physical, or at least cannot be entirely described by the laws and equations of physics. That's why no less a figure than Eugene Wigner, Nobel Prize winner in physics, said materialism is, quote, not logically consistent with present quantum mechanics. Now, he wrote that in 1961, but quantum mechanics has not changed. So he says materialism is not logically consistent with quantum mechanics. And another great physicist of the 20th century, Sir Rudolf Peierls, said the premise, and he's basing this on quantum mechanics, this was in an interview about quantum mechanics. He said the premise that you can describe in terms of physics the whole function of a human being, including his knowledge, he said including his knowledge and his consciousness, is untenable. There's still something missing. Now, I can't explain in detail how quantum mechanics leads some people to these anti-materialist conclusions. I can only give very brief indication, but if you want to read much more about it, you look at my book, Modern Physics and Ancient Faith. So, as I said, quantum mechanics is about probabilities. That's what you calculate in quantum mechanics, probabilities of future outcomes. But this leads to a conundrum. At some point, the probability of an outcome must be converted into a single definite outcome, or else the probability didn't mean anything. It makes no sense to talk about the probability of an event unless at some point there's a definite outcome. So I can say Jane has an 80% chance of passing the French exam, but what does that mean if at no point does she ever definitively pass or fail? If she's never going to get graded and get a definite outcome, talking about the probabilities of the outcome is meaningless. And so the problem in quantum mechanics is that the equations of physics in quantum mechanics, the equations do not yield definite outcomes, ever, except, well, in special cases. But they generally yield only probabilities. So if everything were described by the equation, if everything is described by those equations, things would be forever trapped in a limbo of probabilities with nothing definite ever happening. But if nothing definite ever happens, then what were those probabilities the probabilities of? That is the essence of what is called the measurement problem in quantum mechanics. And in the traditional way of getting around that conundrum, it was this. You appealed to observers, and you said observations or measurements have to give definite results. If I measure a particular observable, I've got to get a definite result. So it's the observations and measurements that give the definite results. But since the equations of physics do not yield definite results, something must be evolved when in the process of observation and measurement that's not captured by those equations. And that leads to the conclusion that the observer is not completely describable by the equations of physics. Of course, we have bodies and we're made up of atoms. So we're almost completely described by physics, but there's something about us that is not described by the equations. Otherwise, you get into this vicious circle. Anyway, this goes back to this argument actually goes back to John von Neumann in the 1930s. And I don't know if I have a quote from, I don't. But just to illustrate that some philosophers come to the same conclusion, the distinguished philosopher of physics, Hans Halvorsen at Princeton University, said in one of his papers, in the case of quantum mechanics, if one presupposes physicalism, then one quickly lands in the measurement problem. And so that's, I think, where I'll end. The one other thing I could talk about is free will. Because here's something that we have direct empirical evidence of. We all experience our free will. But if everything is physical, it's very hard to make sense of free will. And so that's another piece of evidence against physicalism. And that's why most people who are physicalists, most atheists who think everything is just physics, deny the reality of free will. It's very hard to see how genuine freedom in the traditional sense a physical system can have it. And so many atheists who are physicalists say free will is an illusion. It's not real. And I think this is where we are on very solid ground, because I think all of us, by exercising free will, are aware of we have this power, and that if we do have this power, that's a direct argument against physicalism. And that's where I'll stop. Thank you.
Steve, as people ask questions, could you please repeat the question for the...
I will, okay, if I can hear it. Yeah.
How would you explain, like, Forbes' 2008, like, polyvagal theory of, like, the neurophysiological makeup of emotion, self-regulation, attachment, and communication? Because, I mean, wasn't it also Chesterton that said that, like, materialism is pretty easily to, like, I don't know, argue against, because their entire argument and their, like, efforts toward argument implies that there is an entity they're arguing against in the first place.
I'm going to have a hard time repeating that question. What's the first sentence? How would I explain the
Because, like, recently there's more, like, theories, like there's the polyvagal theory.
The
Vagal theory?
I'm not familiar, because I'm just a particle physicist, so that's
Okay.
out of my... And that's in the theory that explains...
It's the neurophysiological makeup of emotions, attachment, communication, and self-regulation.
Right.
And, like, I think scientists like that who, like, recognize that we experience things as humans that other animals don't, but
Right.
also the theories about them are a lot, like, harder to debunk than maybe, like, materialism.
Yeah, so there are theories about our emotions and attachments and things like that. I would say I actually am more of a reductionist than many of my friends who are. I do think you could. I think that I don't think you can explain a lot even of a dog or an animal's mind. In particular, its consciousness, its sensations, and so on. I don't think it comes from physics. I do think it's a natural phenomenon, but it's not physics. There's something beyond physics there. I mean, it's clear that animals have emotions and not just sensations, but emotions, attachments, affections. A dog have affection for its puppies or for its master and so forth. And so I think emotions, in a certain... They certainly accompany and in some degree are explained by physical and chemical processes up to a point. But and I think when I make these arguments, other people make these arguments. Some materialists or physicalists think that we're saying, and this is probably not an answer to your question, that we think that when a dog tastes bacon, we're invoking miracles or the supernatural or something religious. No, consciousness and things like emotions, affections, and so on, which animals have, are natural phenomena. They're not physics, that's all I'm saying, about those things. They're just not physics. So I have no doubt that animals have, and a lot of our emotional and a lot of our mental life and a lot of our mental faculties we inherit from our animal forebears. Our affections are similar to the affections of a dog or other mammals, you know, and our attachments and a lot of those things we have in common with animals. And they clearly are a natural phenomenon. They're just not physics. I'm saying there's more to the natural world than physics. And so I guess that's the only thing I can say about that. There's something even mysterious about the natural world when it comes to mental phenomena like emotions and so on. Of course, with humans, you're entering a completely different level because we don't just have emotions and attachments and so on and sensations and other and consciousness. We have these other higher faculties which presumably other animals on Earth, at least, don't have, which is reason and free will. And that's where I think you not only go beyond physics, I think transcending matter altogether. As the Catechism says, we have the spiritual soul entering in, and you're at a higher level. But anyway, I'm not sure that answers your question, but I think we should say we're not denying our continuity with animals, and that a lot of our mental life is inherited from our animal forebears and is natural and deeply connected with matter. It seems to be part of nature that when you have certain physical structures there, you have consciousness. And when you don't have those structures, you don't have consciousness. And not only that, but particular kinds of physical effects have particular mental consequences. You affect these particular cells in the brain, you lose color vision. There's a set of cells in the brain, in the visual cortex called V4. And it's been shown if you damage that little region of the brain, you see things in black and white. There's clear, close connections between the physical and the mental. And so we're not denying any of that. And that there's some kind of natural causation there. But it's not physics. You can't derive that from physics. That's part of my talk. Anyway, yeah.
Moving in the opposite direction, right, a lot of the arguments made for why humans have a unique soul come directly from Aquinas, who, at that time, science hadn't progressed enough to show as much about animal intelligence as we have now. And so as more and more we're seeing that things we thought were solely in the realm of human intelligence have been replicated by animals.
Okay.
Most of these arguments feel like they would apply just as well for animals having an immortal soul.
Okay. So the question is, some of the classic arguments made by St. Thomas Aquinas and others that only humans have spiritual souls were based on the fact that they were on assumptions that they were making that because they were living in a time before we learned how much intelligence some animals have. I think they would have a good answer to that, and probably actually gave this answer, but I'm not as well read in Aristotle and St. Thomas or. Yes, it's not. Animals are certainly clever, and there's some striking examples of things that crows can do in problem solving, especially, apes, some apes, gorillas, chimps, but also crows and dolphins and certain other animals have a great deal of intelligence of a certain sort. Do they have abstract thought? They weren't just, and here is where philosophers will debate endlessly, but they would make a distinction between being able to solve problems and having a certain kind of cleverness, and are you thinking abstractly? So does the crow have abstract concepts when, they do really amazing things like you give them a thing of water and there's some food floating in the water at the bottom of this sort of tall test tube kind of thing. And their beaks aren't long enough to get to the food, the bread, or whatever floating in the water, so they start dropping stones into the water until the water level rises and then they can reach it. Now, my own view is a lot of that cleverness is probably based on algorithms that they use in nature to survive. I mean, they're solving problems of a sort that they face in their natural environment. I was once astonished at the intelligence of our dog when I was a kid. We had this dog who was a mutt, and it was really smart. And I was really impressed when I was a kid because someone came to the front door and he was barking his head off trying to get at, he was not a very friendly dog, trying to get at this interloper, and then suddenly it's like a light went on in his head and he ran to the back of our house, all the way to the back of our house and to the back door, because as I thought he was reasoning that by going out the back door you can then go around the house. And I thought that's pretty darn clever problem solving. Then I realized later, when I thought about this years later, yeah, but that's the kind of problem that they're solving all the time in nature. They're trying to get away from predators or get at prey. They're trying to find ways to escape from things and find alternative means of egress from where they are and so on. That's a kind of problem that they're solving in nature and probably have algorithms hardwired into them to solve it. But the point is not whether they are clever. The question is whether they're engaged in truly abstract thought. And here's an argument that suggests that they're probably not, that I find persuasive. Abstract thought in humans, anyway, is closely tied to language. And and I recommend a book by Chomsky and Berwick called Why Only Us? And they claim, the book is filled with very sophisticated arguments from animals, intelligence studies, from linguistics, from evolutionary biology, from computer science and neuroscience and so on. They claim only human beings have language in the true sense, in the sense of being able to construct sentences of arbitrary complexity and length. We have language which has what they call hierarchical syntax. So I could say the man who was riding in the car that hit the dog that belonged to Joe, who was the president of this, or I can construct, because we have its hierarchical syntax. No other animal, even songbirds that have sentences of a sort, have this kind of hierarchical syntax. Our closest relatives are the chimpanzees. They don't have sentences. The most that they can do is have 2 words, sentences in which there's no grammatical role. It's not like a verb object. They will say banana, want, or banana, give, banana, give, banana, banana, banana. They just have 2 words put in association, but they don't have sentences the way we do. And so only we, the title of the book is Why Only Us? Only humans on Earth anyway have language in that sense, and that seems to be closely connected with our ability to think abstractly. And so I would claim, as clever as animals are, I would tend to believe that only we on Earth, among terrestrial creatures, have abstract thought. ETs, there may be a lot of them out there that also have it, but yeah.
Does chaos theory, which governs the weather and the positions of the planets, is that susceptible to probabilistic prediction?
Yes, I mean, well, chaos, some people invoke chaos theory or the unpredictability of things as a way of allowing free will. Is that what you're getting at?
I mean, it seems to be that it doesn't have the probability of quantum physics, it seems to.
Right, it's very different from quantum physics. So true chaos, I don't study chaos theory, but my understanding is actual chaos is something observed only in deterministic systems. So in classical physics, where the equations are deterministic, you have chaotic behavior. But as I understand it, based on what I used to read about this stuff, chaos is actually a characteristic of certain deterministic systems. And so it's not contrary to determinism. In principle, if you had actual exact knowledge of the initial conditions of a chaotic system, you could exactly predict what it would do. The trouble is you never have in practice exact knowledge, and the thing about chaotic systems is even a slight change in the initial conditions has enormous changes in the behavior of the system. It's very sensitive to these, hypersensitive to these conditions, and since you never know them exactly, in practice they're not predictable. So you can't predict the weather more than a few months in advance, maybe a few weeks, because even tiny changes in the initial conditions will have dramatic changes in the outcomes. But nevertheless, in principle, you could, if you had exact knowledge, an angel or Laplace's intelligence that had exact initial knowledge of initial conditions could exactly predict, even in a chaotic system. Quantum mechanics, you don't have true chaos precisely because quantum mechanics is not deterministic. So people talk about quantum chaos, but it's not, it's only by some vague analogy. True chaos implies determinism. Yeah.
So I'm here looking for the butterfly effect of how we can educate our youth so that they're open to not be deterministic. You know, is it the formation of excellent writers? Is it the formation of excellent rhetoric? What would help our youth to not be so stuck into this world that we've talked about today?
Well, it's an interesting question. How can we help our youth not get sucked into some of this deterministic or materialistic or physicalistic thinking. My broad answer that popped into my head is keep them away from other youth. No, I mean, I know this from my own kids, is especially the youngest. I have 5 kids. I think the culture has gotten so toxic, and the kids are so much influenced by other kids. We don't live in a culture anymore where children are sort of looking to adults for sort of how to grow up. In the olden times, kids, the whole thing about kids is that they were sort of preparing to be adults. But now, kids are really immersed in youth culture and they interact with other kids. They don't care what adults have to say about anything. They're just influenced by their other kids, TikTok or whatever. I don't know. So that's the basic problem, I think, is that they're coming into equilibrium, to put it in physics terms, with their environment of the youth that they're dealing with. On a more happy note, I think getting them to ask questions, getting them to think about fundamental things. Why is the world orderly? Why does the world exist at all? What's life all about? The kids are just thoughtless. They don't stop and think about these things. What's the purpose? What's the purpose for your life? What's the meaning of your life? That kind of thing. Get them to think about deep questions. If you talk to an atheist who's an adult and they say, oh, you can explain everything from the laws of physics. Say, okay, why are there laws of physics in the first place? They haven't thought about that in most cases. Why are there laws of physics? Get them to think about that. We say it's because there's a lawgiver. What do you say? Why is there a universe at all? Why as opposed to absolutely nothing? So I would say get them to ask questions. But there's some good news. I heard a lecture some years ago from a very well-known sociologist who's a professor at the University of Notre Dame, who's a convert to the Catholic faith, named Christian Smith. And they've done these very big surveys or studies of young people, following them through the years. So they do longitudinal studies of kids and why they lose their faith. And one of the things they found is that a lot of children are not, on the science-religion question in particular, they're not prepared when they're teenagers. They're not taught anything about how to think about science, the relation of science and faith. They're just not taught anything about it. Then they go off to college and they meet somebody and they say, oh, didn't you know that science and faith are incompatible with each other? And they say, oh, I didn't know that. And then they lose their faith. In other words, they're totally unprepared. And the thing is not being presented with sophisticated arguments. They're not being presented, well, they're just being told by their friends, hey, science, religion is unscientific. How can you be religious and be a scientist? And they just collapse. And the good news is if you give them a little formation, some facts and arguments, that will probably keep most of them from just collapsing when their college roommate tells them that that you can't be religious and scientific at the same time. And the good news is there's lots of stuff out there now that they can use. I plug the Society of Catholic Scientists. We have on our website a lot of good materials. So we have something called Common Questions about Science and Faith. So go to our website, look for Common Questions. We have 16. These are questions that high school teachers told us are the most commonly asked questions by their students about science and faith. And so we got the 16 most common questions. We have what we think pretty accessible, good answers to them. Also tell them most of the great scientists throughout history were religious. We have on our website biographies until, say, the mid-19th century. We have short bios, readable bios of about 100 important scientists of the past. Almost all of these people were people who left a lasting mark on scientific history, whose names live on in their fields, who were believing and practicing Catholics. It was carefully curated. We don't put anybody's name up there unless we have clear evidence that they were believing and practicing Catholics, at least at the time they died. And these were important figures in the history of science. And so I think if they read that, a lot of people had a very big effect is produced by the myth that most scientists throughout history have been atheists. That is the myth that science and religion have been at war for the last 400 years. since Galileo. If you show them how many of the great scientists, including Galileo, were religious, it would, I think, have a powerful impact. And so I would go to our website and look at that, and look at the stuff we have there. But fortunately, there's a lot of good pedagogical material out there now that didn't exist 15 years ago. Yeah.
In regards to this connection between religion and physics, it seems that you were saying that our free will we get that because of the uncertainty principle.
No, I don't say that, and that's a common misconception. From a Catholic point of view, and I say from a philosophical point of view, for those, if free will is real and not an illusion, I mean, traditional notion of free will is we have the power to do this or that in a particular situation, we actually have the power to actually do this or to do that action. If the world is deterministic, as classical physics said, we cannot have that power. It's ruled out because I can't decide to pick up this because what my arm is going to do is entirely determined by what was happening a billion years ago in the equations. So I can't go against that without a miracle or something. I can't go against that. What quantum mechanics does is not give us the power of free will. It creates a space for free will by saying that there are multiple things that we could do, none of which violate the laws of physics. In a situation, there's A, B, and C that can happen, all of which are consistent with the equations of physics. The power to choose freely is a spiritual power. So it creates this opening for free will. It removes the shackles from us that the equations of classical physics had put on us. But it doesn't empower us to make rational choices or to have free will. That's a spiritual power, not reducible to physics. It creates an opening for free will. It doesn't generate free will. Okay? Yeah.
I was going to, you filled in some of the gaps. I was going to start with your original premise about the subjectivity of the awareness of redness, and then the neurobiological question and how do we answer it. But it's starting from physics, so that might have age-associated ADD developing. So my thought process was, okay, from what I've heard, biology can be broken down to chemistry, chemistry can be broken down to physics, physics to mathematics, and you describe mathematics as being the characteristics of things, which you might also argue is also true of physics, because you can't have physics without a universe to participate in it, and then write up the scale of those things. So none of them in themselves explain existence, but since the topic is physics, it seems that the only thing that explains all of that is metaphysics, which is why is there anything at all,
right,
like you said. So is that where we start teaching our students, because of the fact that we have self-awareness of self-awareness, and artificial intelligence is rightly called artificial because some intelligence created that. So if we are also computers the way artificial intelligence is, who designed us?
Okay, so there are a lot of questions there, but let me start with why does anything exist? So this is so if you go back to the early church fathers, and I stumbled on this some years ago, when they're talking about reasons to believe in a creator, reasons based on the physical universe, because there's other reasons to believe in a creator, but they were talking about how does the created world point to a creator, and they're talking about how to argue against their pagan contemporaries who did not believe in a creator God. And so they said creation points to its creator primarily in two ways. One, by the fact that it exists, there must be a source of being, and second, by the fact that the world is orderly. And you see this over and over in the church fathers, starting in the 2nd century, all the way over, like they're like a broken record, which is an expression young people would know what that meant. But they're always, it's the orderliness, the lawfulness of the world. So let's take and that means there must be, as Saint Irenaeus said in the year 2000, there must be a giver of order. So take the existence of the world. I would say, why does, as Leibniz said, why does anything exist at all? Why does the world bother existing? Why does it exist? There's only two answers that anyone until recently has ever given that I'm aware of. One was there is a cause of the world's being, and that basically leads you to theism, that there's a source of being. And that leads you to say there is some being who exists by necessity, and that's God, who is the source of being to everything else. Or you say there is no cause or reason for the world's existence. It just does exist as a brute fact without any explanation. That's the choices. There's no explanation, there's no answer, or there's an answer, and if you trace that back, you eventually get to some cause of being, and that leads you to traditional ideas about God. Recently, by the way, this is a counterexample. A lot of atheists say religious people don't think. They don't ask questions. They just think what they're told, and they never ask questions. Actually, we ask two very important questions. The atheists don't seem to ask themselves. Or if they do, they say there's no point in thinking about them because they're unanswerable, so let's stop asking. Why does the world exist and why is it orderly? We ask that. We say there's a giver of being, there's a giver of order. There are laws of physics because there's a lawgiver. We have an answer. They have no answer. But recently, the answer has been proposed to why there's a universe given by people like the late Stephen Hawking towards the end of his life. He said, and also Lawrence Krauss goes around saying the same thing, but most famously Stephen Hawking towards the end of his life was saying, quantum gravity explains why there is a world. Because if you have the laws of quantum gravity, the universe brings itself into existence by a quantum fluctuation through the laws of quantum gravity. Now, that argument was exploded by a physicist just as smart, if not smarter, than Stephen Hawking. And you know who it is? Stephen Hawking. Because in 1988, Stephen Hawking, in his first popular book that was a huge sensation, A Brief History of Time, he asked the right question at that point. He said, why? He said, all that any theory of physics gives you is a set of rules and equations, mathematical rules and equations. That's all a theory of physics is, a set of mathematical rules and equations. And therefore, it cannot, and that was what it cannot explain why there is a universe for those rules to describe. Why there's a universe for the rules to describe. He said, what breathes fire, he asked. What breathes fire into the equation so that there is an actual existing world for them to describe? And the analogy I use to explain his argument, which is this. The laws of physics are to the universe like the rules of a game, like the rules of chess are to a chess game, for example, or the rules of baseball are to a baseball game. So the laws of baseball tell you how baseball games begin, how they end, what kind of events can happen in the baseball game, how one kind of thing happening allows another thing, causes another thing to happen, what order they happen, and so on. It governs how baseball games unfold. I could have the complete rules of baseball. They do not tell me one thing. They don't tell me whether there ever has been a real baseball game, is now, or ever will be an actual baseball game played. They could be rules of hypothetical, possible, and fictitious baseball games. Nor do the mere rules of baseball have the power. The mere rules have the power to cause there to be an actual baseball game. And in the same way, what Hawking was saying is the mere rules of a universe, and there could be other types of universes with different rules, but the mere rules of a universe of a given type do not have the power to make there actually be a universe of that type that is described by those rules. And I think that's an unanswerable argument. Either he forgot it or chose to forget it later in life. Because then he went around saying that the laws of quantum gravity explain why there's a universe. But he answered that definitively, it seems to me, in 1988. And so I think you could say, why does the world actually exist? Either there's no answer, that's the atheist response, just does. Or there's a source of being, that's the theist answer. Both of those are logically consistent. But what makes no sense is to say the laws of physics cause it. That is a ridiculous answer, actually. The atheist answer makes sense. It just says there's no answer. It just exists. Get used to it. It's a fact, Jack. Or you can say there's a source of being. That makes sense. But to say the laws of physics. And so that's what I would say to a young person is that why does the world exist? This is the argument goes back, ancient argument. Why does anything exist? You have your choice. If you're satisfied, I happen to think the theistic answer is more satisfying intellectually. Yeah.
Ironically, yesterday I watched a presentation on the Shroud of Turin, and it was actually done, it was a discussion, and I hate to bring it up in a Dominican parish, but it was a Jesuit priest who's apparently a very strong scientist, one of the world's experts on the Shroud of Turin, which, as you may know, is a photographic negative. And this guy went through all of these laws and etc. that basically said to have produced that, you would have needed something like 500,000 powered lights for 1/400 billionth of a second and some other thing. So he is basing this miracle, if you will, on the fact that it's a miracle. You can't explain it with those laws.
Okay, so this is about the Shroud of Turin. I want to make one point about that. Not about the Shroud of Turin specifically, though I've read a lot about it and find it very interesting. One thing I should say is that the role of miracles in salvation history has never been to prove the existence of God. And if we're talking to atheists, so we're dealing with atheists, unbelievers, it's not to prove the existence of God to people who don't believe in God. If you look at the Bible, that's not what miracles were for. All the miracles of Jesus were performed in the sight of almost entirely of devout Jews who already believed in God and in the Creator. And some Romans, pagans, I suppose, but they weren't to prove that God exists. They were to prove that some particular person, usually, they were to show God's love and concern for us, and they were to show also that some person spoke with divine authority behind him, Moses, or a prophet, or Jesus himself, or the apostles. The miracles sort of were certified that they spoke and acted in the name of God, because only God can cause the miracle. So if this apostle or Moses, if a miracle happens at his behest, that shows he is with God. But it's not to prove God exists. If you look at the early Christian writers, when they're talking to non-believers, they don't generally point to miracles. They point to the order and lawfulness of nature. They don't point to remarkable, exceptional phenomena that depart from the order of nature. They point to the order of nature and its lawfulness as evidence of God. That's the classic argument for a creator. Not the miracle, but the orderliness of nature. Of course, we do believe that departures from the normal order of nature happen, but that's not the way you argue with an atheist. So that's just what I want. We want, especially if you're dealing with scientific atheists, pointing to things that can't be explained scientifically is not the way to go. You want to point to the orderliness and lawfulness of nature as pointing to God. It's because the big misconception now is it's nature or God. It's things have natural explanations or God is the explanation. It's an either or thing. And so I think pointing to miracles reinforces this fundamental misconception. This is something with no natural explanation, and therefore that shows there's a God. What we want to show is that nature itself is evidence of God. As St. Paul says, it's the created world itself in all of its order and lawfulness that points to God. And so we want to point to the laws of physics as pointing to God. We don't want to leave the laws of physics to the atheists and nature to the atheists, say, well, we're over here with God is doing all the stuff that nature and the laws of physics can't explain. No, nature and the laws of physics themselves point to their to the Creator, because the laws of physics are God's laws. And a historical fact I only learned recently from a Protestant historian, the idea of laws of physics comes from Descartes and Newton. The idea of mathematical laws of physics came from Descartes and Newton in the 1600s, both of whom saw those laws as laws imposed on the material world by God. Because they already believed in the lawgiver, because the Bible itself describes God as giving laws to the cosmos. So the Christians already believed that there is a lawgiver to the cosmos. And so Descartes and Newton took that one step further, and they saw these equations as laws imposed by God on matter. So the very concept of laws, mathematical laws of physics, has Christian origins. And I think that's the direction we should go in dealing with the scientific atheist.
Yeah. Oh, I wonder if you go back one slide.
Okay.
A special question.
Yeah. I'm keeping people too long.
We're going to start with a bunch after this.
Okay.
I think I can take it.
Oh, one slide. I should go back one slide.
Okay.
Herman Weil.
Okay. Question from that? Okay. Yes?
You first.
So there is, you ended your talk about the talking about free will, and there is the usual discussion about the foreknowledge of God not being compatible with free will.
Yeah.
Usually the thing is that if you have complete free will, God doesn't have complete foreknowledge, and if God has complete foreknowledge, you don't have free will.
Yes.
That's the recent discoveries of physics, as we point out in your book, point anything more to this topic than that is traditionally